Hi folks, it's Dr. P. Today I'm going to talk to you about using the BK Precision 875B LRC Meter. So this thing is good for measuring resistance, capacitance, and inductance. I recommend that you use it to measure capacitance and inductance. For resistance, I recommend using the Fluke tabletop multimeter, which at this point you hopefully already know how to use. So the first thing to note about this thing is that the on-off switch is on the side. Make sure you turn that on. And the second thing to note is that this thing has two modes. One of them is called LCR and one of them is labeled D. So we want the LCR mode. D measures the dissipation factor, which we will not be using. So you can see that there are three different areas depending on what we're measuring: capacitance, resistance, or inductance. So for measuring capacitance, the first thing to note is that we need to make sure that our capacitor is discharged. So most of the capacitors that we're going to be using are relatively weak in that they cannot store a lot of charge or a lot of voltage. So to discharge them, honestly, you can just short the leads together with a screwdriver. If you're ever doing this with a larger capacitor that's capable of holding a lot more voltage or charge, then clearly you're not going to want to just use a screwdriver. You can use a large resistor value that you can kind of just like short out the capacitor with just a large high wattage resistor, and that'll do the job in a more safe way. So the first thing is that when we measure something, we want to have an idea of what we're expecting as far as the values. So I have a 1 nanofarad capacitor here, this little ceramic guy, and I want to make sure that I use the highest precision scale. So I'm going to go to the 2 nanofarad scale, which is capable of measuring anything that's less than 2. Greater than 2, and I would have to use the next higher up. So in order to accurately measure this, I want to make sure that I've zeroed out the display. So right now the display has 0.07 written on it, which means that that value, negative 0.07, is going to be added to whatever I measure. So I'm not going to be getting a very accurate result. So in order to zero this thing out, we need to zero it with the leads that we're going to be using. And right now I just have banana plugs connected to to alligator clips. I know you can't see the whole wires, but that's okay. You want to hold them open so they're not shorted together. They're not connected to anything on the circuit board yet. And you want to use a screwdriver and adjust this until it reads as close to 0 as you can get. Once we've done that, then we can place the leads across the capacitor and get our capacitance value. So this is 946 picofarads, right? 0.946 nanofarads. So another thing to note is whatever unit on this dial is the unit that's going to be used on the display. So if you're not sure, is this pico, nano, micro, milli? It's in this case going to be nano because it's on the nanoscale. So you always want to make sure you're zeroing on the scale that you're using. And one thing I want to point out too is that holding the leads when you zero this is going to make a big difference, right? Because your body has some capacitance. So make sure when you're doing this that you're not touching any of the metal at all when you're zeroing this out. I also have this is a 1 microfarad, so let's do this. So with an electrolytic capacitor too, we have to make sure that we respect the polarity. So I want the COM to go on the low potential end, and I want the red lead to go on the high potential end. So this is 1 microfarad, so I'm going to put it on the best precision scale, which is going to be the 2 microfarad. And again, I want to zero this out. So I zero it open, and I'm making sure that I'm not touching the metal of either of these leads. And I'm getting it close. Doesn't have to be perfect. Just keeping in mind that that offset is going to change the value that I get. All right, so I'm just, again, this part is pretty straightforward. And again, this is 0.965 microfarads. I know it's microfarads because I'm looking at what the dial is set to. Whenever you're using the 2 microfarads and up measurements, it is recommended in the manual that you calibrate it on the 2 microfarad mode. So you zero it out on this scale and then change to whatever scale you need. You're also advised to use the short leads that come with the LRC meter. I don't have a set of them at home, so I'm not using them. I'm using banana plugs with an alligator clip. But again, for high capacitance measurements, you're going to get better results with those shorter leads. So that's what you're going to have, but I also know at your station that you've got banana plugs and alligator clips, so I just want to advise you to use the best tool that you've got. If you change the leads that you're using, you do want to re-zero things. The whole point is that when we're using this zero adjust, we're kind of subtracting out the capacitance of our system. And our system consists of the wires, it consists of the alligator clips, it consists of everything. All right, so next we're going to use this to measure inductance. So the big difference with inductance is that when we zero things, we want to have our leads shorted together. Okay, so we also have to have a feel for the scale that we're using. So we want to find the scale that's appropriate. So this is a 100 millihenry inductor. This is also 100 millihenry, so I'm going to measure just one of these, which means that I want to go to the 200 millihenry. So I want to make sure I'm on the best scale. And again, what I'm going to do here is I'm going to zero this out. Again, shorted. And get close to zero as possible. Similarly, I'm in the millihenry mode on the dial, so the units I'm getting are in millihenry. So I'm going to just connect, and I see that this is 99, nominally 98.999 millihenry, close to the accepted value, so that's good. The strange thing that happens with this LRC meter is if I want to measure two 100 millihenry inductors at the same time. So I'm going to show you what happens. So I was kind of lucky in that I got a little quick readout, so that kind of gave me an idea of what was going on, but it's reading that the value is kind of too high. And when the value is higher than the mode it's set on, so anything greater than 200 millihenry makes this 1 show up. And that's true for not just inductance, but also capacitance and resistance, which means I need to go to the higher up level. And then if I try to calibrate this in the higher up in the 2 Henry reading, I see I get that 1 measurement. So when I get that 1 scale, the equipment manual says to basically go to whatever closest range you can go to zero this out. So this is already zeroed out in the 200 millihenry range. So I'm going to go to the 2 Henry range, and I'm going to place my leads across my inductors. And wouldn't you know it, it's reading way off. There's no way that 2 100 millihenry inductors is going to give us a value of 376. I don't know why this device does this, but it does. And it's really annoying. So how on earth are we to measure anything that's got an inductance of 200 millihenry? The answer is we're going to have to measure each one individually and then sum them together. So I go back to the 200 millihenry mode. I measure one of my inductors, right, 98.3, 98.4. I measure the second one, 98.6, and I just sum those together, and then I know what the total inductance is. Again, it's possible to use this to measure resistance. We do want to measure the resistance of our inductors because parasitic resistance is non-trivial, especially in these large value choke inductors. So to do that, you're just going to measure in parallel using the Fluke multimeter, the tabletop, or we're not necessarily going to use resistance measurements on this thing because we've got a better tool for that. So again, the big takeaways are make sure you zero. When you zero in capacitance mode, you want to make sure your leads are open. And you're going to individually go on every mode until you get to 2 microfarads. If you're measuring 2 microfarads and up, you're going to zero it on the 2 microfarad mode. For inductance, we're going to measure with those leads shorted. And we're gonna zero out on like if we go to a measurement scale that doesn't allow us, if we get that 1 point, right? We're not allowed to zero there. We're going to go to the next closest scale that allows us to zero there, and then measure our inductor. All right, folks. Hopefully that helps you understand the LRC meter. When you're finished, make sure you turn it off to preserve the battery life. Until next time, stay well.